Good morning, everyone. My name is Mugumbia Benon from Makerere University. I'm going to continue our discussion on the car price prediction model that we have been going through in this series. So, what do you expect to talk about in this in this presentation? I want to talk about the problem solved, AI environments and agents, dataset description, informed and uninformed search, relation of that to our project, AI accountability, and relating AI accountability to our project. So first, we are going to talk about the problem solved. And since our model from the past videos have been talking about how it predicts prices for the different products, the problem there in that we are solving is that we'll be evaluating and predicting the price of used cars in order to standardize the industry standards of used cars on trading platforms. This can also solve the problem of rationality of used car prices and allow sellers to sell at a price they're willing to take on and buyers to understand the value of goods. So basically, we just want to standardize the price because with this model, sellers can set prices slightly above the standardized price. So a buyer can have confidence that the price of the vehicle will be almost relatively the same at different locations within the world, and they will have that forehand knowledge that will guide their spending and choice of a vehicle. So we're going to talk about an AI environment, artificial intelligence environment, and agent. Of course, the AI environment, if just to talk about AI environment, is where our agent operates, and the agent is the actual is the actual model we deploy. So our model is environment. Our AI environment, and AI environment is where the model operates, and the agent is the model itself, a basic description of what they are. So the environment our model is going to use is our model is environment is a fully observable environment as a data set is fully furnished with training data regarding all the different aspects required to make a price prediction. So generally, our environment for our model will be feeding it with different attributes and then to make a prediction. So our data set in this case is also part of our environment because basically we'll be feeding in the exact attributes it needs that we can observe in order to train our model or for our model to work. So that in that case, our environment is an observable environment. And on the other hand, our agent is a software because it's not a robot or anything. We're just dealing with a software that can run on web browsers and phone applications. And in that case, there is a classification for software agents, which is a utility-based agent because it's just helping to determine the utility and help people with their daily billing and price determination. So we go on. So we are going to describe our data set like we saw a data set earlier on, and this is just a complete description of our data set. Our data set comprises of 19,237 entries and a total of 18 columns. The different attributes of our data set include the price, the levy is the tax, the manufacturer, because different car models have different prices depending on the manufacturer, the year of production, the category. Of course, cars have the categories: SUV, sedans, leather interior, fuel type, engine volumes, mileage, cylinders, so many attributes. All these attributes have a significant contribution to the price of a car in the end. So that's why we needed a data set that has these different attributes. Then our model will be able to determine, to learn and understand how the price comes about, because all these different attributes have a significant contribution to the price of a car. The gearbox, the wheel drive, whether it's two-wheel or four-wheel, the doors, the wheel size also matters, the color, and the airbag, whether the car has an airbag or not. Of course, most of our entries within the data set have these attributes attached against them. Now we are going to talk now about the informed and uninformed search. Just to describe them, an informed search algorithm contains an array of knowledge, such as how far we are from the goal. So an informed search is basically when you're searching, you already have forward knowledge of what you're looking for. So you know how far the goal is, then you can determine the path using that knowledge you have at hand. Whereas an informed search is a class of general purpose search algorithm which operates in a brute force way. In other words, uninformed search is blind. You don't know where your goal is, but you just know the different routes you can take. So our model is in an informed search. In an informed search algorithm, do not have additional information about the state or search space other than how to traverse the tree. The tree is basically the different routes we can take when we are searching. So it's also called a blind search because our model just more of a try and error, trying to find out where the goal is. We don't have that forward knowledge of where the actual goal is, like in the informed search. So in this case, the informed search and uninformed search have a certain relation to our project. If I'm taking the case of the informed search, uh, our model is an uninformed search to make a prediction using training data set. This will be majorly searching for a target name or category. The way we can apply uninformed search. Sorry. So in the first case, using uninformed search to make a prediction, we'll be using like initially when our model is still, could I say still new, whenever you give it like a query feeding data, it just goes searching within a data set without that foreknowledge of knowing what the actual goal is. So it just keeps following till it finds that that specific thing you're looking for. Then in the second case, when you use uninformed search, here the goal is to basically store our search histories. When we store our search histories, the model will be able to use that search history in future to make a prediction. So in that case, we'll be using an informed search. Imagine people search for the same kind of specification and are trying to predict. So the model will have a record of that and to just draw from that history and search using basing on that info, that history, and make an informed search and determine exactly where our goal is. So AI accountability. AI accountability simply refers to the need to explain and justify one's decisions and actions to partners, users, and others with whom the system interacts. AI accountability is basically in case our AI does something wrong, or it has done something good, who is accountable? Who takes, could I say, the blame? Who who is the front man of our AI model? That's basically what AI accountability is. To ensure accountability, decisions must be delivered in a deliverable form and explained by the decision-making algorithm. You should be able to deliver and explain your results. In case you make a model, you should be able to explain how it's doing it and everything, so that we may be able to understand the security integrity of the model. Basically, we should be able to account for everything that AI does, so that we can be able to see if it's acting in ways that may not be socially accepted. Then, how we are going to relate AI accountability in our project is for our project, we want to use a disclaimer message which will be employed to notify users of the fact that the prices we're predicting are just near predictions. So they should know that the actual price market may vary for the product because of course, the different market forces of demand. So here our user will just be in the knowledge that these prices are not final, so that the user may not have an issue of saying I budget the AI made this kind of prediction. I budgeted my money accordingly, only reached the market, my budget was insufficient. So in that case, the user should be well aware that this is just merely a prediction, but that prediction will be so close to the market price, so they can budget slightly above the prediction just to be on the safe hand. So our references for today are listed out there, and I'll be sharing the slides. So thank you for today, and have a nice day.